All right, now that we know that the integral of secant cubed, we know what that is, we can start tackling this integral. So here's our integral, here's the picture. So we can see from the symmetry of the picture that the first thing we could easily do is rewrite this as 2 times the integral from 0 to 1 of the square root of 9 plus x squared dx. All right, so here's the substitution that we're going to use. When we had 9 minus x squared, we used the substitution x equals 3 sine t. So if I have a square root of a squared plus x squared, then the substitution I'm going to use is x equals a tangent t. So in this particular case, we're going to use x equals, since we have 9 here, we're going to use 3 tangent t, because that's a squared, right? So a squared is 9, means a is 3. So we're going to use x equals 3 tangent t, and then we need to track what the dx is as well. So dx is equal to 3 secant squared t dt, all right, because the derivative of tangent is secant squared. Now we need to do our change of limits again. So when I have x equals 0, then I have 0 equals 3 tangent t. And the only way that that's going to be 0 is if tangent t is 0, and that's going to happen when t equals 0. So that's nice. But then when I have x equals 1, my limit up here, I have to solve 1 equals 3 tangent t. And that means that tangent of t equals 1/3. And that means that t equals the inverse tangent of 1/3. And that's not reducible. If it was inverse tangent of square root 3 over 3, I would know what that is. If it was inverse tangent of 1 over square root of 3, I would know what that is. But I don't know what the inverse tangent of 1 over 3 is. It's irrational. It's not going to be a nice number. It's not on the unit circle. All right, so now I can rewrite my integral as a equals, I have my 2. My integral from 0 to 1 is going to become integral from 0 to inverse tangent of 1/3, 0 to inverse tangent of 1/3. And my integrand, which was 9 plus x squared, now it's going to be 9 plus 3 tangent t squared. So it's going to be 9 plus 9 tangent squared t. And then my dx is going to become 3 secant squared t dt. So 3 secant squared t dt. All right, then I do the usual trick. Let's get this limits down first, inverse tangent of 1/3. So the usual trick is to factor out the 9 from here. When we factor it out of the square root, it's going to become 3. So I have 3 square root of 1 plus tangent squared t times 3 secant squared t. So here you can see what the trick is, why we used tangent here. So we used sine when we had a minus sign here, because we have a trigonometric identity for 1 minus sine squared. Well, if I have plus instead of minus, what's a trigonometric identity that has a plus in it? Well, I know that 1 plus tangent squared is equal to secant squared. So that's the reason we use tangent, is because it has an identity that has a plus sign in it. So we'll go ahead and use that. So I have 2 times integral 0 to inverse tangent of 1/3. Let's go ahead and put the 3's together. We got 9, and then I have square root of, instead of 1 plus tangent squared, I'm going to put secant squared t. I've already put that 3, so now I just have secant squared t dt. And probably you can see by now why I needed to know the integral of secant cubed. Because now let's pull the 9 all the way out. So I have 18 integral 0 to inverse tangent of 1/3. Square root of secant squared is just secant. So I have secant t times secant squared t dt. So I have 18 integral 0 to inverse tangent of 1/3 secant cubed t dt. All right, so fortunately, I know what that is. We just found out that the integral of secant cubed t dt is equal to all this stuff. It looks like a horrible mess, but it does solve the problem. So that's what we're going to put in next, is we're going to put 18 times 1/2 secant t tangent t plus 1/2 ln absolute value of secant t plus tan t, evaluated from 0 to inverse tan of 1/3, and then we'll finish that up in the next video.